Hey guys, welcome to DevOpsSchool. In this video tutorial, we are going to learn about Kubernetes. Kubernetes is developed by Google and it is an open source platform that automates container operations. It eliminates many of the manual processes involved in deploying and scaling containerized applications. After going through this tutorial, I promise you that the concept and understanding of the Kubernetes will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOpsSchool certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai, and in Pune. Simply compare our many courses, find the one that suits your style and schedule best, and start today.
Okay guys, so let's get started. Now, so yes, we need to learn nothing but what you want to desire. If you learn what to desire, you will declare in YAML or JSON, send it to API server to kubectl, and then rest of the things will be done. That's all. And they will maintain your desire, not you. So everything will be done by them. So very first element, very first API resources, API object, what you have in the Kubernetes is pod. So yeah, we've been ignoring this topic, what is a pod, from long time, but we know that pod is been created by kubelet. In where? Worker. Pod has container. Container is created by Docker, which you know. Pod may have multiple containers, that we know also. In the one worker, you may have a multiple pod also, that also we know. Pod gets IP address from the kube proxy, that also we know. All the containers of the pod share the same IP address, that also we know. Correct? So, this is what we have understood from the pod, right? Correct, guys? Hello, can you hear me?
No, all the pod will have same IP address, that's the correct one?
No. All pod has a different, each pod will have a different IP address.
Okay.
So guys, what is a pod? So guys, understand this way. When I say create a VM, so who's managing the VM, by the way? When you say create a VM, start the VM, whatever it is, who manages the VM? So VMware manages your VM. So when inside a VM, what you have? Ultimate operating system and application. So when we say create a container, so who create a container? Docker. What you have inside the Docker is whatever you have in image, you know that. So same way, pod is not understood by Docker. Same way, in Kubernetes, a platform like a Kubernetes has a pod. So pod is the atomic unit of scheduling. So you say, right, you want to run some application, so run in the VM. Last 2 days I've been telling you run in the container. Now in the Kubernetes world, you will say run in the pod. Yes, run in the pod. Now the question is, what you have inside a VM? You have operating system. What you have inside a container? Users with root file system. What you have in the pod? Containers. That's the difference here what you have. Inside a pod, what you have? Container. So see here. In the VM, you can host any kind of operating system. You know that very well. In the virtual machine, you can host any kind of operating system, any flavor of Windows or any flavor of Linux. So same way, inside a container, you can have any kind of images, any images. It's not like only this image you can run, that image you can run. No, any images you can run. Same way, in the pod, you can have any kind of container, any container. So in the pod, you have any kind of container. Now, how the VM is running? You know that. VM is running because of the PID1 is running. And container is running because of the PID1 is running. VM is running because of the PID1 is running, and PID1 is here, system D. Container is running because of the PID1 is running, and PID1 is here. It can be anything. Now the question is, what is a pod? When the pod is running? Pod is running when containers are running. Understand that one more time. Pod is running. If there is one container, the container has to run, so pod is running. If it has a multiple container, all containers has to run if pod is running. So in short, what is a pod? Pod in Kubernetes is a way to schedule your application runtime environment. That means it's not run application, is the Kubernetes. It is an atomic unit of scheduling. Pod has a container, pod has a container, pod is running, containers is running, pod is running, and this is a pod. Now let's deep dive into this. Pods have a container, which we discussed, multiple containers. Okay. Pods here in the Kubernetes, in the Docker session, I've been telling you, container uses all the pod environment such as kernel namespace, network state, and stuff like that. But in the Kubernetes, pod gets that all the namespaces. Just so. In the Kubernetes, pod gets all the namespaces like IPC, network transport, and so on. Not containers. Here is the pod. So all containers in a pod share the same environment. This is called tight coupling. When you have two containers in the same pod, one of maybe application, one is a database, this is called tight coupling. Sometimes developers say, no, we have to run these two applications in the same environment. It has to be. So keep it in one pod, two containers. This is called loose coupling, one pod, one container. Okay? Think about it, why one image is wrong and why one image is right. Think, any clue? Anyone would like to share your input on this?
Same application in a single pod is not possible.
So if any pod goes down, right, like okay, the other pod's loss of protection.
So see, pod will have the IP address. So if the pod is down, then all the application inside the pod will go off. So it would be better if you have the container in different IP addresses, meaning like different pods.
Yeah.
The load balance will work.
So first, right, all Nginx in the one pod, all Nginx container in one pod will not run on the same port. That's the first disadvantage. Second one, even though if you change the port of the image and you will run the application, but what you will do, because you will not be able to load balance all the containers, you will be only able to access one. Because pod gets IP address, not a container here it gets IP address. And you will load balance with the pod, not a container. Right? So all the four containers will get wasted if you RAM and all. Yes, this is the way you should scale. When you are scaling, you should make sure that one pod, one kind of pod, one kind of container should be in one port. Now guys, when you have a multi-container pod, when you have a multi-container pod, first container is called main container, whereas the second container is being called as a sidecar container. This is the terminology which we use: main container, sidecar container. First container is your main container, second container is sidecar container, or third container is a sidecar container. See here, pods share all the environment and same time pods are atomic. Pods can be scaled one to many. See here, one pod you can make it a two pod also. So that is possible. These are the life cycle of the pod. Now in the container session also we have said container life cycle. Anyone remember the container life cycle? I forgot, I guess. What was that life cycle of the container? We learned day one only.
Create, stop, pause, and stop.
Yeah. So guys, pod cannot be in a create state, something like that. Here you have a pending state. The moment you initialize the pod, remember pod is not a physical entity. Containers are physical entity. Pods are just a wrapper. The pods, whenever you initialize the pod, I said initialize, then pod is in pending state. And when it's a pending state, look at the container's color. It's in gray. That means container is not running, pod is not running. Then container is running, so pod is running. Now container failed, pod gets failed or succeeded. Okay. So that is the thing. So pending, running, succeeded and failed. These are the life cycle of the pod. Look at this. If you have two containers, main container and sidecar container, how can you access from outside? IP address of the pod and then port number. You know that. Okay. This is the way. How can each pod connect with the other pod? Through the pod networking implemented by QProxy. Pod network, remember, pod networking is implemented by QProxy, which is the third element of the worker. How the pod will connect with each other internally? Container. Through the local host. But from outside, IP address and port. Same way. So guys, what is a pod? Pod has one or more containers. Pod is being called your application or service. The most basic unit of work in Kubernetes. In Kubernetes, if you want to schedule the work, it's a pod only. Pods are inferal, understand that. Inferal means one pod once is created and destroyed, that you will never get back. That means the pod got succeeded and failed, you cannot get back to the running state. Repeat. No pod is ever redeployed. That means pods are inferal. Atomicity, they are there or not. Simple. What is the job of the Kubernetes? Kubernetes job is to keep your pods running. More specifically, keeping your desired state. Pods should be up and running, health should be available, and liveness program. So, this is all about the pod. So now, did you understand what is a pod? And pod is the first most important API resources of Kubernetes, which you declare in the YAML or JSON and send it to API server as to the things you know that. So guys, did you understand what is a pod?
So one question, you said, right, the pod will have all the namespace of the VM, right? I mean, for an OS. Is that the correct statement? Or
get the namespace. When I say namespace, kernel namespaces. Remember the kernel namespace like a PED, net, MLPs, and
yeah, like container or like VM has multiple namespaces, but for only running an application, we need specific namespace, right? Do the pod will have the same or like how?
Sorry, your question is confusing. I'm getting confused. Tell me.
In the very first class, right, we spoke about the namespace which is required to run an application, right? So pod will also have only those namespace?
Yes, yes. So application required operating system. Operating system is equal to boot file system, root file system, application file system, and user file system. Whereas in the pod, it is not having the file system, but this one, what is it? Network files, network namespaces, and this one, mount, if you externally mount to the pod, and PID, and all this stuff. So these are the kernel namespaces actually I'm talking about. So whatever it was used to get assigned to container, now it will get assigned to pod. Which are the namespaces will get assigned? This is the one. Net namespaces, ICC namespaces, and mount namespaces will get assigned to pod, and anything which is assigned to pod will be accessible by container also. In short, I will tell you in simple way. Pod is by basically kind of wrapper which hold the different containers without network, without mount, without access. So that means if you have a container, multiple containers, so they'll be sharing the network, IPC, mount, and
so the container will have their own, the mount, right? Mount and everything.
No.
So that is,
okay.
when we deploy in the container will have its own namespace, right? So once we deploy in pod,
So
it will have it or not?
container will have a user namespace and MNT namespace from the image. Okay. And if you associate anything with the pod label, then that also container can access it.
Okay. So pod will override the container.
Not overriding. Allocation will be done at the pod label, and whatever is allocated to pod will be shared by the container of that particular pod also. Shared container.
Okay.
Okay, guys. So now that is all about the pod. So more or less we have explained the pod. Now if you want to have a multiple pod, then you will have to, it's not a programming language where we have a 4 is equal to I and I is equal to less than 5 or something like that. No. It's a declarative language. So if you want one pod, you say pod kind is equal to pod. I'll teach you that one and show you that one. But if you want the multiple pod, then you use the API resources which is called replication controller. Nowadays we use a deployment also. Now the question is, what is the differences between the replication controller and deployment? That we will discuss little later. But right now, yes, if you want a multiple pod, then you can use a replication controller or deployment. So far that is okay. Services and all we'll discuss little bit later. So now we'll get back to the demo part. Okay, guys. So this is the discussion so far we had. So let's conclude that. So guys, I know so far in the Kubernetes world, you have a master, you have a worker, you have workstation. But I forgot a list of components which is in master. Can you please help me out?
API server.
API server, what else?
Scheduler,
Before it.
controller,
No.
ETCS having a key data.
ETC. Scheduler.
Worker, anyone remember?
Queue proxy. Kubelet.
Second.
Queue proxy.
Or CTL agent. Correct, no? In the workstation?
kubectl.
Okay, fine. Well, tell me one thing I forgot. Who initiates or who initializes or who's creating a pod?
Initiate or like scheduler creates the pod, right?
Scheduler create a pod? Sorry, I got little bit. So I'm saying who creates a pod, not schedule. Anyone, guys?
Kubelet.
Kubelet. And guys, inside the pod, if you have a container filled by
Images. And then
container is created by
Docker.
Docker. Correct, right? Yeah. Docker. Docker container comes from
Docker images like.
yeah. And image comes from
Docker side.
registry. Okay, guys. So, guys, here you think about it. Kubelet creates pod. Pod has a container from image from registry. So, guys, you know, Kubernetes says to everyone, if you want to run application, run in the pod. Everyone. Because Kubernetes is a platform for the managing the pod, scheduling the pod. So they say to everyone to run in the pod. Now, if they say everyone to run in the pod, can't they run their own application in the pod? Yes, they should run, right? So they should run their own application in the pod also. So here, yes, guys, this is a pod. Pods come from container. Pod has container. Container comes from the image. Image comes from the registry, and here this registry is called Google registry. Yes, hub.docker.com, the one which you have learned, that is okay. But we do have one registry which is called Google registry as well. Okay, so it comes from the Google registry. So, on the same line, this is also pod. This is also pod. This is also pod. So guys, tell me, in the master, all these applications is pod. So who creates a pod? Kubelet. So don't you think so Kubelet and Docker should be there also, because pod is created by Kubelet and Docker is creating a container. So don't you think in the master you should be having Kubelet and Docker as well? Don't you think so?
Yes.
Yes, guys. So yeah, in the master you will find all these components. These all are pod. This is a agent. This is a daemon. So this will be running without a pod. So Kubelet and Docker utility and this one. And in the workflow you will be having this one. And the workstation you will have this one. Whereas proxy is also should be here. Because if this is a pod, you will get IP address by the proxy itself. So guys, this is the real architecture which we have. Master has all 4 components plus these 3. Worker has only these 3. Workstation you have QC. This is a complete picture of Kubernetes architecture. Everyone got it? Everyone have understood this? Okay. Now next question is how to set up cluster. When you say cluster, that means Kubernetes cluster. How to set up Kubernetes cluster. So guys, there are so many ways are there. One node cluster for learning purpose. Multi-node cluster for QA production. Now the question is, how can you set up a multi-node cluster? So you want to set up in the cloud, private, public cloud or private cloud? Private cloud, public cloud. When you say private cloud, you want to set up a manual, automated way. Public cloud, you want to set up manual, hosted way. I think I need some water. Yeah. So private cloud, manual. How do you set it up? There is a utility which will set up a cluster, KubeADM. Automated way, COPS. Okay. Manual here, public cloud, you can use COPS again. Hosted, so many. EKS on the AWS, GKE, Google Cloud, AKS, Azure, and many other platforms. So overall, this is your way to set up a cluster. Again, apart from this, there are 40 different ways are available. Using that, you can set up a cluster. When you say one node for the learning purpose, you can use Minikube also. So Minikube is basically single node cluster only. So single node cluster only. So guys, overall, these are the setup. As part of this training, we are using manual way KubeADM. Everyone uses this one only, but on top of that, they have automation wrapper and stuff like that. So as part of training, we will use KubeADM to set up a cluster. Any questions, guys?
Private means in-house data center.
You have set it up your own data center using VMware, vSphere and all. So that's called private cloud.
Public manual means
What is that?
Public manually means like public means AWS.
Public means, let's say AWS. Public means AWS, and there you created a EC2 instance and you set it up using manual, using COPS. You can use the KubeADM also. So like that. One of the ways I'll teach you, KubeADM way, understand that. Okay, so now the question is how to set up a cluster using KubeADM. And KubeADM. Guys, so far so clear. Any questions before showing you the demo? Because the same demo you have to do that as well. Any questions? Any doubts? Any questions? Any doubts?
I have, can we edit like a container? In a Docker, we go into the container and we can edit that inside the container, no?
Yeah,
inside PODS is also possible like that?
No. PODS, if you want to change, you have to change the desired in the API server. If you change directly to the pod, it will become a static pod that will not be managed by Kubernetes. You can create a pod without a Kubernetes also. You just need a kubelet to create a pod. But those pods will not be controlled by Kubernetes, so it will not be managed by a centralized mechanism. Okay.
Okay.
Okay, guys. So I'm going to set up a cluster now. So let's understand this. Each one of you have got the CentOS box 1, CentOS 2. CentOS 2, you will make it a master. Again, I'm repeating. CentOS 2, the place where you have not done anything, you will make a master. And CentOS 1, you will make it, the one which you have used it for Docker, you will make it worker. Okay, that way, this is non-use server, which you are setting a master with, and this will be worker. Any issues, we will get an error or something like that, I'll help you with it. Not to worry. But this is how. So I needed 2 machines. How do you get the instruction for that? So for that, I am going to get you the instruction. And the same instruction I will also follow in front of you. This is a way to set up a cluster in Ubuntu. This is the way to set up a cluster in RHEL. Okay, here it is. This is the steps for that. Now guys, you will read this. What is KubeADM? Okay. If you want to go and do it to Google also, KubeADM is a way to set up a cluster. You can read more about the GitHub website, which is here. It's a product, free product, open source product. You will read that KubeADM. What are the goals we have? Why do we need it? What are the prerequisites you have? All these things you will read it. And then installing Docker. Let me tell you, all this URL you will be opening in the same box where you have a VM running. Remember, don't open up in your browser. So probably, I don't know, some of you might have issues. Prerequisite installing Docker. Remember, each machine you need a Docker. Here also you need a Docker. Here also you need a Docker. And here you need KubeADM also, because KubeADM will set up a master. And here also you need a KubeADM. For worker purpose, kubectl you can have here also. Here also. So these are the utilities you need a worker. These are the utilities you need a now master. Whereas this is a pod, so I'll move up. So total pod you will have 5 in the master. These are the utility you will have in the master. Whereas these 2 pods you will have in the worker. And then these utility you will have in the worker also. Okay, in the workstation you have kubectl. Okay, so now these are some of the utility I discussed about it. Step 1. Again guys, you will go read, do it slow. Okay. So here, every step you have mentioned, validated multiple times, you will do as I suggested. You will go to the VirtualBox and change the hardware address as per the image. Step number 1. Step number 2, change the host name of the master server. Again, do not run commands blindly. This is the command. You should change something like your name. Let's say your name is Rakesh, so rakesh.master.com, like that. Do not run command blindly. Do not run those commands. So everyone host will become rajesh.master.com. This is not good. Then you have to stop the firewall, disable the firewall. And then you have to disable the swap also. Command to disable the swap is here. Here I have been given instruction to shut down and reboot the machine. Reboot the machine, reboot the VM. So step number 1, step number 2, step number 3, and step number 4. You will do it in your VM. Okay. So is that clear for everyone? Any questions, any confusion?
This is for which master VM?
I'm talking about the master. First we are setting up the master here. Okay. See here, we are setting on the master. Okay. Worker will set up a later. Now you need to install Docker. The installation instruction you have here to install the Docker. Now till step 4. I don't have to do that because I have a AWS instance which has all this 1, 2, 3, 4 done. You have a VM, so you have to do that. Then install the Docker. The installation instruction is here. You have to enable and start the Docker. And after that, you have to add the repository where you will find all these software. Okay. Here, I'll do in front of you. After that, you change the permission mode, SRE permission mode. These commands are there. And finally, this command will install all these utilities required in the master. And finally, this is a magical command, step 9. This init will do a lot of things. Remember, kubeadm init will be run in the master. Again, I repeat, kubeadm init will be run in the master and it will set up a master. Init will set up a master. After running this command, you will get some output. You have to store this output at any cost. I repeat, the output or whatever you get, you have to store that output at any cost till tomorrow. Okay? Till tomorrow. And after that, step 11 onwards will set up a workstation. And then step 14 onwards will set up a node. Again, 11 onwards, workstation. Setup 14 node worker. Okay, and this is what we have to do. So now I'm doing in front of you. You will not get confused. Okay, so please look at my screen. This is the AWS. I need one machine which has a 2 CPU, 4 GB RAM. You have a sufficient infrastructure. One more thing, again I'm repeating. Make sure that you are setting up the VM which you have not used for master. Okay. So I will delete this node. Terminate. Go and create an instance. I'm doing from scratch. Look at my screen here. You have a VM already up and running. CentOS. Marketplace, CentOS 7, continue, two CPU, 4 GB RAM, configure instance, one machine, I'll give 30 GB hard disk is more than sufficient. Tag it, name with master. Configure security. I've opened up all the firewalls. Not good practice, but just for the learning purpose. Launch. Key. Launch. So guys, I got 2 CPU, 4 GB RAM instance, and now I can use to set up a master. This is the machine. This is IP address. I got it.
It is mandatory to have 4 GB, like 3 CPU core.
Not mandatory. So let me show you the the requirement what you have for master is, I have documented. In fact, you can read the documents also. And here, minimum requirement is this one. 2 GB or more RAM per machine. It's recommended. And 2 CPU. So 2 CPU or more is recommended. So if you have a 2 GB RAM also, it's okay. But I got a little bit of to save time and speed up. 2 CPU, 4 GB RAM. These are the minimal requirements. Again, detailed documentations you have over there. You can just refer. Okay. So now, I got the IP address. This is the machine. I'm going to do the putty. Auth. PPK. Open. Yes. Let me improve the view. Colors. 16. Click OK. Apply. Guys, CentOS. I'll become a root. Okay. See, I become a root. Now I'm doing this here. Look at it. My thing. Step number 1 not required for me. For you. This is for you. This is for you. This is for you. You will do that. Directly I'll jump to installing Docker. Remember. So I'm installing Docker now. Commands I just copied in from the same location. And in front of you I'm doing it. So you can just see it very carefully. Don't get lost. Understand each and everything. And do it with a peace of mind. Because if you one installation get corrected, it's very difficult to correct it. I mean, it's not very difficult, but again, lots of time gets wasted. That is a problem. I'm installing a Docker right now. And finally, enabling the Docker for tomorrow. And finally, starting the Docker. Same border. Right. After that, I'm going to add this repository. This is the way. See selected what I selected. Look at this. That's doing carefully. Add it. Finally, set Linux post setting for 0. Copy paste this command carefully. Done. And finally, this command will install lots of utility. And finally, and then one last command init. See here. Master setup is in progress. Version is 1.19.2. Okay, guys, please read this. Your Kubernetes control plane has successfully. You have to copy this. Again, I'm repeating. If you do not copy this, you will waste time. So you have to copy this, store it in your notepad, in your personal notepad. And then, if you get this message, your master is set up successfully. So your master setup is done successfully till step number 10. From the step number 11, you have to set up a workstation in the master node only. See here. Workstation, it can be in a different machine also. In a different machine also. See here. Look at this nice thing. This is master, you set it up. Now workstation. It can be in a different machine also. But right now you are doing in the same machine. So which command you will follow? Here. Look at this. Carefully. This command. This command is one for setting up the workstation. To start using your cluster, you need to run the following as a regular user. So I am a root user right now. Can I be a regular user? CentOS, I become a regular user. And here, I will create this directory. And you need not to be regular user. It's up to your wish. It can be root user also. Depends on how you wish. And now I set up a workstation. I run the same command. Now I have to validate. How do you validate? Get nodes. Not ready. All the namespaces, all the pods, done. So guys, I have set up workstation also. Now I need to install the networking, pod networking. Okay. So because if I do the get nodes, it says not ready. So now I need to install networking, and for that what I will do, run this command. Copy it very carefully. VNet. Done. Now let's check it out. Nodes. Wait for a few seconds. Don't be impatient. It will take some time. If you think you can't run the command, just watch. Not ready. Not ready. Now ready. So within 30 seconds after installing the network, pod networking, it will become ready. So guys, I followed the step number 13 and my workstation and master both got ready. Worker, it has to be done in the different machines. I will not show you the demo right now because before that, I want you to set up a master and workstation both. Guys, did you got all this stuff? Was it difficult? Any questions? Any questions, guys?
No questions.
Okay. So here is the complete instruction. You have a machine. Again, I'm requesting you all to use the master machine, which you have not used so far, fresh machine. This is for the setting up the instructions for the workstation, and this is for the pod networking. The command, exact command, I have it for the VNet here. Okay, so you have everything. I'm updating the notes right now, and I'll give you 30 minutes to set up our cluster. Worker, I'll set it up at the end of it. Okay. So I'm updating the nodes now. And I'll give you 30 minutes to set up a master. Go ahead. See your time now.
Rajesh, we can use Tempo as 1 or 2.
That's what I said, sir, right? Here I said very clearly, use the machine for master which you have not used so far. I think you have not used CentOS 2 machine VM, so use for the master. Okay guys, go ahead.
Thanks for watching. If you liked our Kubernetes session so far, please enroll for our channel membership $399 plan to get access of all the parts. Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.